Afternoon, everyone. I know it's the end of another GopherCon, and by this point, you probably have a problem that you weren't even realizing that you would have at this point. But you all have probably far too much swag than you know what to do with. So, in the next 7 minutes, we'll build a parser for a plain text accounting thing to help you keep track of all of those conference stickers that you picked up along the way. So to do that, we're going to use a tool called the Parsing Expression Grammar, or a PEG. And this is a tool for building parsers that gives you a very readable grammar that will also, it may not generate the most efficient parser, but it will be one that is pretty maintainable over time. So to do that, we're going to use the Pidgin Parser Expression Grammar Generator. And you can get that using this go get command. This is the format that we're going to parse. It's got some fields here. We have a date, a payee, several different postings to different accounts, and currencies in stickers, because why not? So the first part of a PEG is the code block. And so this is going to appear at the very top of your PEG, and this is some verbatim code that Pidgin will place into your parser. So at minimum, you need to have the package statement in here because Pidgin doesn't know which package it should generate your parser in. This is also where any imports that your PEG uses directly should appear. After that, we have the definition of our grammar rules, and this follows this format here. We have a rule name followed by a left arrow, and then this rule can refer to other rules. It can refer to literal strings, and even things that look vaguely like regular expressions. These things would otherwise be in something like a scanner, but it's pretty nice that we can incorporate them all into one file. Also in here, we can have some optional Go code which will run when that rule matches. So we have some basic primitive rules that we're going to use here. We have a digits and a letters rule, and you can see here that digits is just a sequence of any numbers that we encounter, and letters is basically the same except it's a capital and lowercase letters. And all we're going to do is just convert those into strings. Pidgin defines for us that C variable for us, which is the matched text. We also have to deal with whitespace in this grammar. So we have 3 rules here for a significant new line, a significant space, and just any white space that is optional. So notice that we don't have any action blocks here because we don't have to do anything in particular with that white space. We just want to have it be parsed and discarded. So with these primitives, we can now start parsing our individual pieces of this format. So an account here is built up of that letters rule, followed by an optional sequence of a colon, followed by more letters. And when we encounter that, we just want to turn that entire thing into a string. Moving on to an amount, that's composed of 8 digits, followed by a required space and the literal string stk. So we're going to use string convert to convert the captured digits into an actual integer, which can be used by other rules. So looking at the entire posting now, we can grab both the account and the amount, and we can return a posting struct from that rule where we can set an account and an amount field from that. Now that we have our postings, we can now parse the entire transaction. I'm going to skip over date and payee because they're kind of similar to the amounts and accounts that we looked at earlier. This time, we're actually going to call a function to do this because it's a little bit more involved. The transaction part is similar. The only difference here is that since we can have one or more postings, Pidgin is going to return that to us as a slice of empty interface. So we first have to convert the empty interface that we receive into a slice of empty interface with a type assertion. Then we're going to iterate through that and then type assert the individual empty interfaces within that to postings. So now that we can parse a transaction, we can parse the entire ledger by just repeating that transaction multiple times. And this functions similar to the posting rule that we saw before. So now that we have our grammar, we can generate it using Pidgin on the command line. I like to put this in Go generate because I can never remember the flags for this. It works very well with Go generate. Once you've generated that, you get three functions out of that. You get parse file, you can pass readers to it, and you can also parse slices of bytes, which is really fantastic for testing. And I wish that I had time to show you a demo of this, but unfortunately I am time constrained, being a lightning talk. So I will get a demo of this up on GitHub, and I'll be happy to share that on Twitter. This is my Twitter handle. I'm Tim Raymond. I'm a partner at Gopher Guides. This is our logo. I hope you enjoy the rest of the lightning talks. Thank you very much.